Hello, future AP Computer Science students. This is Mr. Goldsmith, and this video will tell you about the Scratch portion of your summer project. By the way, later in our class, you will be making videos like this that show your own programs running. So the first thing I'd like you to do is please follow this link to scratch.mit.edu, and that takes you here. Scratch is a free, open programming language made by teams of students and professors at MIT University, so that's kind of neat. If you've used Scratch before, it might look and feel a little different now. It went through a major update in January 2019. And the very first thing that I'd like you to do is please create an account if you don't already have one. On our class page, on the assignment page, are some instructions for what your username needs to be. That's going to help me keep everything a little organized for the whole class together. So please pause and go ahead and create a Scratch account and then come back to this video. Welcome back. And the first thing that I'd like you to do in Scratch is please browse some projects that other people have made, shared, and posted. Now, when you look at the front page, you'll see a different collection of projects than what I see here because it is updated every couple of days. But I see everything from a music project to a game to some art projects, some educational work, learn more about the ocean, and a lot of diversity and creativity, a little puzzle in the types of things that people have made. So I'd like to check out one of these. It'll take just a minute to load. And this is a little game someone made and someone shared. The green flag is how we begin and play. And this game has some sort of neat, kind of floaty motion controls. And it's fun to play. You can explore that. But most importantly, for any posted Scratch project, you can click See Inside. And what you're looking at now is the collection of programming that makes this project work. So as I scroll, I see several connected chains of blocks put together by assembling these blocks on the left. And this game has multiple items. It has the player's character, it has the finish line, and a few other things. As you click on each of these, you'll see they all have their own separate programming instructions that they're following. Even here on the right, the background has its own set of programming instructions. So what I'd like you to do now in just a second is please pause this video, explore some of the other posted projects. You can have fun interacting them and using them, but most importantly, for anything you check out, please click See Inside and explore how the video is made. So please pause, come back when you are finished with that. Welcome back. And now we are going to create our own Scratch project by clicking on Create. Now, the neatest thing about Scratch is it's so simple that I know a second grade teacher who teaches Scratch to their students, but at the same time, it is so powerful and lets you build things that are very, very complicated. UC Berkeley teaches an entire programming class in this language. So don't feel that even though it kind of has an elementary school look and feel, that you can only do elementary school level projects. In fact, when you look at the posted projects, you'll see a lot of power and complexity there. So we are going to begin making a project of our own, and any script needs instructions for how it's going to begin. In fact, the first thing I'd like you to do is please browse through the entire list of instructions that are available to us. And one thing that you'll notice is that any or many of the blocks have drop-down menus. Like here's a block with some math functions, but then within the block, we see that the math functions available to us include trigonometry, sine, cosine, tangent, logarithms, and quite a few other things. So please become familiar with the list of blocks that you see here. It's not like you need to have it memorized or anything, but just explore what's here. And for any block with a drop-down menu, take a moment to see what's inside that drop-down menu. So please pause and come back when you are finished with that. And welcome back again. So we're going to make a little project of our own. We're going to give the sprite 1, Scratch the Cat, some instructions to follow. And he will begin following the instructions when the green flag is clicked. And the first thing that I'd like him to do is go to a certain location. We're going to ask him to go to 0, 0, where he is right now, and point in a certain direction. That's actually the direction he's pointing in right now. What that will do is reset him if he ever ends up out of position. So at the beginning of our program, he goes exactly to the location where he is right now. And I'd like Scratch to move in a square. I could ask him to move forward a certain amount of steps and turn 90 degrees. And walk another 100 steps and turn 90 degrees, and walk another 100 steps and turn 90 degrees, and so on. But the power of programming is that there are often quicker, easier ways to get a job done. So we're going to have Scratch repeat 4 times to move 100 steps and turn 90 degrees. And when we click the green flag to run our program, he does exactly that. Now, I want to be able to see what he's doing, so I'm going to come to Add Extension and add some extra commands to let Scratch have a pen. And there's some neat stuff in those extensions. So at the beginning of our program, we're going to erase any old stuff that's left over, and then we're going to have Scratch put his pen down. So now he's going to draw as he walks, and we can see he draws a square. Well, let's add one extra block. Repeat 180 times. And what Scratch will do right now is draw the same square over and over and over again 180 times. That's not going to be too exciting until we add this. Every time he draws a square, he's going to turn 2 degrees. So the next square will be off by a little, and then a little more, and then a little more. And finally, we're also going to have Scratch change his pen color every time he draws a square. And I'm going to go ahead and click Run on this and also expand to full screen. And let's see what we've made. So what we see happening, of course, is he's drawing 180 squares. After each one, he turns a little bit. So each square is shifted from the previous, and the color shifts a little bit also. And when you put that all together, it makes something kind of neat. And this is the power and beauty of programming. That if you assemble something well, if you build something creatively, something incredibly short and simple can do something incredibly powerful. In fact, I'd like to take a moment and think about how all of this would be broken if this block was put here, or instead put here. And you might want to think about what each of those would do and how it wouldn't work as well as what we currently have works. Now, for your assignment, I'd like you to create a program that involves more than one sprite. This Scratch character is a sprite. So we're going to add a second sprite. And what I'm going to do now is going to be just making a project that demonstrates, and I chose this ball character for the second sprite, a project that demonstrates some things Scratch can do. It's not really going to be a playable game or a project or anything like that. It's more going to be a demo of some Scratch functionality. So we now have 2 programmable characters, Sprite 1 Scratch and this ball. And the ball's also going to get its own set of instructions to follow. It's going to begin following its program when the green flag is clicked, and I'm going to ask it to go to a certain location. I'm going to ask it to go to the location of the mouse pointer. Now, if I run this program once, If I run this program, the ball will one time go to the location of the mouse pointer, then it'll stay there. And if I move the mouse around, it won't move anymore because it'll be at the end of its instructions. But we can add one more block. We can add forever. And now over and over and over again forever, as long as the program's running, the ball keeps going to the mouse pointer, and that makes it follow the mouse like this. And then finally, a sprite can have more than one set of instructions that it follows simultaneously. So I'm going to give the ball character one more set of instructions. If it is touching the other character, sprite 1, we're going to ask it to do something. We're going to ask it to change its costume. And its costumes are just several different colors. So that will change its color. So if the ball character is touching Scratch the cat, it will change its color. Oh, but wait a minute. This is also just going to check once when the program begins and then be done with that set of instructions until we add forever. And notice the way these are arranged with the if statement inside the forever loop. And now we can run this program again. Scratch the cat does exactly what he was doing before. The ball is following two separate sets of instructions. It is always going to the mouse pointer, and anytime it's touching Scratch the cat, it changes its color. So your assignment is to create a program that has at least two separate sprites, like we have here, Scratch the cat and the ball. And at least one of your sprites must have more than one script, more than one set of instructions that it's following. And besides that, I'd like you to have fun, explore, and be as creative and as complicated as you can. There's really no limit to this. The project I've shown you here meets all of the requirements and would earn an A+ if you turn something similar to this in for your assignment. But I want you to explore your own ideas. You may make a game, an art project, a science project, something with music or animation, or anything you decide to create. In fact, the hardest part of this assignment might not be making it, but deciding what you want to make. Have fun, happy programming, and I look forward to seeing you in computer science